Chapter 1, the human. So here we are going to discuss the psychological and physiological attributes of the user, providing us with a basic overview of the capabilities and limitations that affect our ability to use computer system. So it's only way when we have to understand the user at this level, so that we can understand what makes for successful designs. So the overview of the chapter 1, the human, is first of all the information. Before that, we can say that humans are limited in their capacity to process information. This has important implications for design, and we are going to learn that information is received and responses given via a number of input and output channels: visual channel, auditory channel, haptic channel, movement. The information is stored in memory, in a sensory memory, in short-term memory, and in long-term memory. Information processed and applied in reasoning, problem solving, skill acquisition, and the error. We can say that emotions influence human capabilities, and of course, at the end, we say that users share common capabilities, but are individuals with difference, means each person is different. So in this chapter, we will first look at the human's input-output channels, the senses and responders or effectors. So input in the human occurs mainly through the senses, yes, and output through the motor control of the effectors. So there are 5 major senses: sight, hearing, touch, taste, and smell. So the first 3 of these are very important in HCI: sight, hearing, and touch, as long as taste and smell do not currently play a significant role in HCI. So imagine you are using a personal computer with a mouse and a keyboard. So everything, the application you are using have some interface, and when you look to your computers, you can see the interface, and you mainly receive the information or receive information primarily by your sight, and because of from what appears on the screen, yes. However, you may also receive information by ear. For example, the computer may beep at you if you make a mistake, or to draw attention to something, yes, that it is going to say if you want to delete it, you will never restore it, and etc. So touch also plays a part too, yes, because we are feeling the mouse, we are moving our mouse, and according to the mouse we are receiving some information, or we are sending information to the computer using our hands by hitting keys or moving the mouse. And of course, sight and hearing do not play a direct role in sending information, yes, but sometimes we are also send an information to the system. For example, when we are using our Face ID in our phones. So in this session, we will look at the main elements of such an interaction, yes, first considering the role and limitations of 3 primary senses of visual, auditory, haptic channels, and then going to consider motor control. So the first of all is the vision. So the human vision is very complex, yes, so it has its own perceptual limitations or physical limitations, and we can divide visual perception into 2 stages, yes, physical reception of stimulus, and after that processing and interpretation of the stimulus. The eye is the physical reception. Yes, so mechanism that receives the light and transforms the light into electrical energy. The light the light reflects from objects, so and then we can see the objects. Yes, in our uh, in our retina, the images are focused upside down, and the retina contains rods for low light vision and cones for color vision. And these color visions and light visions, the ganglion cells detect the patterns and detect the movements. Interpreting the signal. So the eye is going to receive some stimuli from the outside world, yes? And according to the size and depth, so the visual angle indicates how much of view object occupies. So it relates to the size and distance from the eye. The visual acuity is ability to perceive details. So how acuity, if your acuity of your eyes is high, then you can perceive all the details or see all the details of one image. And if the visual acuity is low, then it's hard to perceive the details of some object. Of course, familiar objects perceived as a constant size objects. In spite of changes in visual angle when far away, we are going to say that the size of something is very slow because it is a familiar object. And cues like overlapping help perception of size and depth is also so it helps us, yes, in the perception of size and depth, but it can be not reliable. So interpreting the signal according to the brightness and the color, we said, yes, the reactions of the levels of light can be subjective. So each person can so each person's reaction to the levels of light are different, and it can be affected by the luminance of object, of course, and it's measured by just noticeable difference, and visual acuity increases with luminance as does flicker. The color is made of hue, intensity, saturations. So cones, we said yes for color stimulus, for perception of color. Cones sensitive to color wavelengths, and blue acuity is lowest. And you know the 8% of males and 1% of females, they have a color blind, so no red and green. Interpreting the signal. After the interpreting the signal, the visual system compensates for movement and changes in luminance. We said according to the luminance, we are going to perceive some objects in a different way, and context is used to resolve ambiguity. For example, look at this shape. It's an ambiguous shape, yes, if it is a 13 or if it is a B. So according to the context, we can resolve the ambiguity. So here, if you look, if I say it ABC, means you will say that this shape is B. But if I show you 12, 13, 14, then you will say that this is the number 13. If you continue here, the optical illusions, the Ponce illusion, the Muller-Lyer illusion. According to these illusions, our perception of size is not reliable. We can see that this rectangle is smaller than this rectangle, or the length of this figure is smaller than the length of this figure. So it's not, they are the same, but our perception of size is not reliable. So optical illusions highlight how we perceive the world and how it is in reality. So in interface design, we should be aware that we will not always perceive things as it is exactly. So reading, the first of all, the input channel. Yes, we are talking about the input channel, the reading. So how we are going to perceive the information? There are several stages of reading, like visual pattern received, decoded using internal representation of language, interpreted using knowledge of syntax, semantics, and pragmatics. And reading involves saccades and fixations. Perception occurs during fixations. Word shape is important to recognition, and negative contrast improves reading from computer screen. Yes, so in average, adults read 250 words, but these 250 words are not read accurately, because when the person is familiar with that word, even if there is an error, that person won't see the error, because the people are perceiving the word with its shape. So we are going to look at the shape of the word, and even if there are errors, we won't pay attention to the error. We will read it. And during the reading, during the fixations, we are going to perceive the information. And the legibility of anything is said to be 9 to 12 times Neuroman. So, for example, as long as we know the shapes of the word, as we said, we cannot find the errors. Yes, that's why when there is an important thing like flight numbers, they are writing in uppercase letter. When there is an uppercase letter, we are going to pay attention to that word and read carefully. Our mind understands that this is an important, and we should look carefully for that word. Hearing. So another way of perceiving information is the hearing. Yes, by hearing. So hearing provides us information about the environment, the distance where it came, the sound, the directions, from which directions came, from objects, which objects are making those sounds. And the physical apparatus of hearing, we have three apparatus. Yes, outer ear, middle ear, inner ear. So outer ear protects inner and amplifies sound. Middle ear transmits sound waves as vibrations to inner ear, and inner ear where the chemical transmitters are released and cause impulses in auditory nerve. So as vision begins with light, hearing is with vibrating of or by using the sound waves. Yes, and sound is divided or changes. Yes, sound is changes, or it is vibrations in air pressure. So it has a number of characteristics we can differentiate. So pitch is a sound frequency. Yes, it is the frequency of the sound. Low frequency produces a low pitch, a high frequency, a high pitch. A loudness is a proportional to the amplitude of the sound. So the frequency remains constant, but the amplitude of the sound changes. And timbre, it relates to the type of the sound. Yes, sounds may have the same pitch and loudness, but be made by different instruments and so vary in timbre. So timbre is like a type or quality. So the quality, or we are in toy, let's say, we can, if someone says our name, We can pick out our name spoken across a crowded, noisy room, yes? However, if sounds are too loud or frequencies too similar, we are unable to differentiate sound. So as you have seen, hearing hearing is used rarely in interface design, yes. So usually it is used for warning sounds and notifications. However, the human ear can recognize familiar sounds without concentrating attention on the sound source. So this suggests that sound could be used more extensively in interface design to convey information to system state or about the warnings or about the notifications. This is about the hearing. Now is the touch. The third and last of the senses that we consider is touch or haptic perception. So this sense is often viewed as less important than sight or hear, but imagine life without it. So touch provides us with vital information about environment, yes? When we touch on something, we can see if it is cold, if it is hot, if it is a glass, or if it is a water. And we can also, by touching, feel its shape, the speed, accuracy of actions. So the touch senses or haptic perception is also important. So it is an important thing to give a feedback while using the computer systems. Even there are some systems used for the impaired person, so braille interfaces, where the primary source of information in the interaction, where people with the impaired senses can use the system. So braille systems, you can look in the internet what is it. So the touch gives us the important feedback about the environment, and it can be a key sense for someone, yes, as we said, who is visually impaired. And stimulus received via receptors in the skin. So the first one is the thermoreceptors that receives heat and cold. Nociceptors, it's receiving of the pain, and mechanoreceptors, it is the for receiving the pressure. And some areas more sensitive than others, example fingers, yes, that's why now we are using the mobile applications that we can touch by fingers and use it. And kinesthesis is the awareness of body position, so it affects the comfort and performance. So movement is, we need to consider the motor control and how the way we move affects our interaction with computers, yes? So a simple action such as hitting a button in response to a question involves a number of processing stages. The stimulus is received through the sensory receptors and transmitted to the brain. The question is processed and a valid response generated. The brain then tells the appropriate muscles to respond. Each of these stages take time. So time the reaction time plus the movement time. Of course, the movement time depends on the age, depends on the fitness, yes, of the person, of the human. Reaction time depends on stimulus type. So visual, it is approximately 200 milliseconds, auditory 150 milliseconds, and pain 700 milliseconds. Increasing reaction time, it decreases accuracy in the unskilled operator, but not in the skilled operator. Yes, for example, when we are going to tap, or when we are tapping the keyboard buttons, if we are more practiced, then we will the movement time is going to be low, and if we aren't the practical with the keyboard buttons, then we are going to use or to spend more time. So here's the fits load, describes the time taken to hit a screen target. So here is the A and B are constants, MT is the movement time, D is the distance, S is the size of the target. So targets as large as possible, distances as small as possible. After the sensory channels, input-output channels, and the motor control, we have the memory. So there are three types of memory. Sensory memories, short-term memories, and long-term memory. So for example, if you have you ever played the memory game? The idea is that each player has to recount a list of objects and add one more to the end. Yes? And there are many variations, and if the objects are related, then we are going to store it, or we can say it without errors maybe. But if the objects are not related to each other, it's very difficult. Yes, so these kind of abilities or this kind of games are rely on our ability to store and retrieve information, and this is the job of our memory. Yes, and as you said, there are three memory types: sensory memories. After that, we are going to take an attention, and that goes to the short-term memory or working memory, and then there is a rehearsal. This is the long-term memory. So the first type of the memory is the sensory memory. What is the sensory memory? It buffers for stimuli received through senses. Iconic memory means visual stimuli. Echoic memory, it is the aural stimuli, and haptic memory, it is the tactile stimuli. So the examples are stereo sounds and the sparkler trail, or and this and the information in this memory is continuously overwritten. For example, the sparkler trail, when we see once and after some time we lose everything that we have seen. Yes, or the stereo sound, we have heard some sound and after that it deletes from our memory, and if we hear the other sound, we are going to concentrate on that sound, and continuously it is going to be overwritten. This is the sensory memory. Short-term memory is the memory where where some information are going to be held in this memory. So for example, 5 times 6, 2 times 3, and plus 5 times 6, and calculated. This is 2. So this short term is used for performing calculations that is going to store the intermediate stages of use. So we are going to remember for some time, do the calculations, and then go further. So this is the short-term memory. Then and also short-term memory, we have the limited capacity, which it use the chunks. Using what kind of chunks? For example, if I gave you some numbers, yes, from 1 to 5, let's say this way, these examples. The first one, this one, to memorize is a little bit harder. If we divide into meaningful chunks, we can memorize it. For example, here we have divided into chunks, and we can say that 0, 121, 414, 26, 26. And this is also, for example, we cannot remember it, but if we look at this message, for example, have A3, and we cannot remember it, try to memorize it and say it. As long as these are not the meaningful words or meaningful things, it is very hard to memorize it. So this is the limitations of our short-term memory. If we take this first T to the beginning, we can say the cat ran up the tree. Now we can memorize it very quickly. After that, there is a long-term memory. So the long-term memory, it is the memory that that stored in our memory here. So this so long-term memory is our main resource. Yes, here we store the factual information, experiential knowledge, procedural rules of behavior. So everything we know is stored in this long-term memory. But of course, it's relatively slow to access the knowledge in this long-term memory. Yes, but there are two types of the long-term memory: episodic and semantic. Episodic means there are serial memory of events, and semantic means structured memory of facts, concepts, skills. So the semantic long-term memory is derived from the episodic long-term memory. So the semantic memory is structured here. The semantic memory is structured, and it provides an access to information that represents relationship between bits of information. It supports inference. So the model way for the semantic memory is structured as a network. So here, model semantic network is when there is an inheritance, child nodes inherit properties of parent nodes, relationship between bits of information explicit, supports inference through inheritance. Like here, dog. What is the dog? Dog has the four legs, it barks, has tail, and dog is an animal, yes, that brass, that moves. Dog is a sheepdog. It works, is a collie, and dog is a hound, and dog is a beagle, and etc. So here we can draw a semantic network. A network of representing the relationship between bits of information and supports the inference. So this is the semantic long-term memory. The long-term memory, there are frames, so we can organize the information in data structures. Yes, so here there are relationship subtypes. Docs, there are fixed, legs, yes, defaults, and variables. And again, there is for Kali also fixed, default, variables. So the slots in structure instantiated with values of instance of data. So the models of long-term memories, one of them is the scripts. So one of them is the frames doing like this. The second one is the scripts. So when you want to interpret the situation, yes, doc ill, doc vet open, owner has money, result, doc better, owner poorer, vet richer, C instructs, etc. This is the model of long-term memory. Long-term memory production rules. So representation of procedural knowledge, yes, condition action rules. If condition match, then they use rule to determine the action. The storage of the information in long-term memory is the rehearsal, means information moves from structural information moved from short-term memory to long-term memory, and the time hypothesis is the amount retained proportional to rehearsal time. Yes, distribution of practice effects optimized by spreading learning over time. So when you are becoming more practiced, then the practice effect it's going to be increased, and the time for learning that is going to be decreased, or the time spent for that time spread for doing that action is decreases. And the long-term memory storage is structured, meaningful, and familiar. If the information is structured as we do with the doc, then we are going to quickly memorize it and have that structure in our mind. And if it is meaningful, again we are going to memorize quickly. Again, if the information is familiar, then it also helps us to memorize it very quickly. So forgetting is of course the information that is in our long-term memory is going to delete it very slowly. Interference, of course the new information is going to be replaced by new information is going to replace the old information. For example, your mobile phones, yes, phone numbers. Before it was a Megacom, for example, and now you use Oshka, and the old information is replaced by a new one. And also our memory may not forget, but it is going to forget selectively, and those memories also are affected by the emotion, so can subconsciously choose to forget. Sometimes you want to forget something and we want to even remember about that. So this is the functions of our long-term memory. When we want to forget, we can forget some information that is very old, or we are going to replace the old information with the new information, or some of the things we want to subconsciously choose to forget. How can we retrieve a data from our long-term memory, recall, or recognition? Recognition rather than recall, it is saved. Why? Because recall means you are going to reproduce the information from your memory, and you are going to find out, like you are going to search for the categories, you are going to search for something, and etc. So you are going to recall some information from long-term memory. But recognition is when you are going to be given for some information that has been seen before, and when you are going to see it, you are going to recognize it. So recognition rather than recall.